In this video, we're talking about some of the different ways we're going to be asked to find the area of a rectangle. And remember that a rectangle is just a specific type of quadrilateral, a four-sided figure, where each of the four interior angles are 90 degrees. So in this first example, we have this complicated figure here, but what you can see is that figure ADLI is a rectangle because I have four 90-degree angles at its corners. So this largest figure here is a rectangle, so ADLI is a rectangle, and I'm going to have rectangles inside of this rectangle. And the dimensions in green are the dimensions that I've been given in the problem, and I've been asked to find the area of three different rectangles in this figure. The first area I need to find is the area of ADLI, which is the outermost rectangle. So how am I going to find the area of that? Well, as a reminder, the area of a rectangle can be found by multiplying the length of the base by the length of the height. So if we call this horizontal dimension here the base, and we call the vertical dimension the height, then we need to find the base of this outermost rectangle and multiply it by this height. We already know that the height is 11, the length of DL here is 11, so we just need then the base. Well, we've already been given the base. The length of AD, we've been told, is 15. So to find the area of ADLI, we just multiply 15 by 11, or base times height. So we get 15 times 11, and that's going to give us 165. So we'll just say 165 square units. What about the area of rectangle CDLK? Well, if I find those points, I have CDLK. So it's this rightmost interior rectangle here. I already know again that the height is 11 because CDLK has the same height as the outermost rectangle, but I'm not quite sure what the base is yet. I don't know the width or the base of CDLK. But I do know that the width of the entire outermost rectangle, the length of AD here, is 15, and I know that the distance from A to C, point A to point C, is 13. So that tells me that if the entire length is 15, and this length from A to C is 13, then the length from C to D has to be the difference between those two, which is just 15 minus 13, or 2. So I can go ahead and write in that the length of CD here is 2, and I can use that as my base. Of course, if the length of CD is 2 and I have right angles in here, the length of KL will also be 2. So I can just say that the area of the rectangle then is going to be base 2 times height 11, which of course will be 22 square units. And finally, if I want to find the area of BCHG, let's go ahead and find those points. So BCHG, so this rectangle here in the upper middle portion of the outermost rectangle, I want to find the area there, so I'm going to need a base and a height. Well, I've already been told that the height of the rectangle is 4, so the distance between C and H here is 4, so I know the height will be 4. I just need to find then the base. Well, for this problem, I've been told that the distance between J and L, points J and L, is 10 units. And when we were finding the area of rectangle CDLK, we found that the distance between K and L was 2 units, which means that the distance between J and K has to be the difference between these two, so 10 minus 2, or 8. So if I say the distance between J and K is 8, I know that the distance between G and H also has to be 8, and that's the base of the rectangle that I'm interested in. So I can go ahead and say that the base is 8, I know that the height is 4, and therefore that the area is going to be 32 square units. So that's one way you might be asked to find the area of rectangles. What about if you're given 4 coordinate points that represent the corners of the rectangle? Well, the easiest thing to do when you're given 4 coordinate points like this is just to plot them on coordinate axes like this so you can get a picture and you make sure you do this problem correctly. So the first point we have is 0, 0, so we can go ahead and plot that right here at the origin, point 0, 0. Then we have point 0, 2. So I'm 0 along the x-axis, and I'm up to 2 along the y-axis, so right here. Then I have the point 5, 0. So I go out to 5 along the x-axis, but I stay right there on the x-axis. I don't go up or down. And then I have the point 5, 2. So I come out to 5 and up to 2. And here's my fourth point right here. And then if I want to, I can go ahead and connect these lines to draw in my rectangle, and now I can clearly see a picture of the rectangle for which I need to find the area. So remember, area is just going to be base times height. So the base length here, the length of the base, is going to start at 0 and go all the way out here to 5, which means the length of the base will be 5 units. So I can say 5 times the height. Well, the height starts at 0 and goes up to 2, so the height is going to be 2 units, and so I can say 5 times 2 is going to be equal to 10 square units. So the easiest way to do this is just to draw the picture. First of all, to confirm that it is a rectangle, and then to verify that you have the right base and height. So that's how you'd find area in that case. What about if we're given a word problem like this? In this case, we actually know what the area is. We're told that the area is 27 square feet, the area of the rectangle. Also, we know that the base of the rectangle is 3 times more than twice the height. So we have a little algebraic expression here we're going to need to write down. We need to find the dimensions of the rectangle. So this is just like working backwards. So the first thing we need to look at is the base is 3 times more than twice the height. So I can go ahead and write this as the base b is, or equals, 3 times more than twice the height. Well, twice the height is going to be 2h, and 3 more than 2h is going to be 3 plus 2h. So I can say the base b is equal to 3 plus 2h. Since I know that the area of the rectangle is 27 square feet, I can also say b times h is going to be 27, because that's just my rectangle area formula. Base times height has to be the area, 27. So now what I can do is go ahead and make a substitution. I know the value of b is 3 plus 2h. I can go ahead and plug that into my second equation here for b, and instead of b in my second equation, I'm going to say quantity 3 plus 2h times h is equal to 27. And now when I distribute, I'll get 3h plus 2h squared equals 27. If I go ahead and subtract 27 from both sides, I'm also going to move this 2h squared to the front. I'm going to get 2h squared plus 3h minus 27 is equal to 0. And now we want to try to go ahead and factor this. So what we're going to get is 2h and h in the front. And then my factors of 27 are going to be 9 and 3. I'm going to want to go ahead and say plus 9 and minus 3. And if I just double check myself, 2h times h, I get 2h squared. 2h times a negative 3, I get a negative 6h. 9 times h, I get a positive 9h. So 9h minus 6h gives me 3h. And then I have a positive 9 and a negative 3 gives me a negative 27. So I know I've done the factoring correctly. Now I want to set each of the factors individually equal to 0. So I'll get 2h plus 9 equals 0, or 2h equals negative 9, or h equals negative 9 halves, or h minus 3 equals 0, adding 3 to both sides, h is equal to 3. Now I have two potential solutions for the height, but I know right away that h equals negative 9 halves cannot be a potential solution, because we're talking about a real height for a real rectangle in real space, and the height can't be a negative value. It's a real dimension, and we can't say that the length of one side of the rectangle is some negative value. So this solution is eliminated, and we know that the height then has to be equal to 3. So now we just want to plug this back in to our b equals 3 plus 2h equation to get a dimension for the base as well. So we'll say b is equal to 3 plus, and then instead of 2h, we'll say 2 times 3, since we already found that h was 3. So b is going to be equal to 3 plus 6, or b is equal to 9. So remember, we were asked to find the dimensions, base times height. We want to go ahead and say that base times height, the dimensions, are going to be equal to, we found that the base was 9, and that the height was 3. So the dimensions of the rectangle are 9 feet by 3 feet, since we were told that the area was 27 square feet. And those are just a couple examples of different ways that you might be asked to find the area of a rectangle.